This lesson is on the cognitive approach for A-level psychology, and it's actually number 3 on the specification for the approaches unit. So you've already done number 1, origins of psychology, number 2, the learning theories, which are the behaviourist and social learning theory, and this is number 3 on the spec, the cognitive approach. So we can see that the specification has quite a lot of details. We're going to go through all of that and the evaluation. And what I would like you to do, if you're one of my students, I've given you handout AP22, which is an A3 sheet that looks like this, so you can pause the video as you go along and just make notes on this big summary sheet. If you're not one of my students, then you can download that from a link in the description below. So the cognitive approach, first of all, the basic assumptions of it are that the cognitive approach wants to study internal mental processes. This means that it's moved on from the behaviourists who would only study behaviours that were observable. The cognitive approach contrasts with that, and it wants to study behaviours that are non-observable. It wants to study the internal mental processes like memory, perception and thinking. So those are things that we can't see, and it wants to study them. And because the behaviours are private and cannot be observed, the cognitive approach studies them indirectly by making inferences about behaviour based on evidence and reasoning. So inferences is a really important word in the cognitive approach, and if you infer something, it means that you deduce or conclude something from evidence and reasoning rather than from direct observation or explicit statements. And so the cognitive approach will do experimentation and scientific studies, and the results from the results they will deduce something about an internal mental process like memory or language or perception, like how do we remember things. And so for example, we make inferences about the characteristics of different types of memory. So if you've done the memory unit, you will know that this model shows the multi-store model of memory, which is a model that is a linear model, starts on the left hand side where it says environmental stimuli, and it shows how information flows through the cognitive system, which is your brain, to be transferred into different types of memory and eventually long-term memory. It's saying how memories are formed. So each of the stores, those boxes that you can see, are different types of memory, and cognitive psychologists will have done experimentation in order to understand the characteristics of those different stores. So for example, if I asked you what is the duration of short-term memory, then hopefully you would tell me it's 0 to 30 seconds, peaking at 18. So you're telling me that your short-term memory can only last about 30 seconds. But the reason that we know that is because some researchers called Peterson did the trigram experiment, where they got participants to recall, they told them a trigram, which was 3 letters, and then they'd follow it by like 3 random letters followed by 3 numbers. And the participant would have to count backwards in threes from that number until the researcher said stop. And then they would have to say the trigram, which was the 3 random letters in the right order. And so what they found was that if the interval was only 3 seconds, then most people could recall the trigram. But once it got to 18 seconds, then only 2% of people could recall it. And it was from that experiment that people could deduce from that the duration of our short-term memory is only 0 to 30 seconds. And then we can infer that, which means that we can infer that that's what our duration of short-term memory is. So the cognitive approach relies on, because it wants to study those internal mental processes like memory, but we can't see memory, it relies on experimentation and then deducing from the experiments, from the results of the experiments, in order to make an inference, to infer certain things about memory, perception and language, for example. So the cognitive approach uses theoretical models, and we've just talked about the multi-store model of memory. So theoretical models are ways, so it says one way to study internal mental processes is through the use of theoretical models. So theoretical models are models like the multi-store model of memory or the working model of memory or lots of other models that show the cognitive flow of information, how it kind of tries to show you through a model how information is being processed in the brain. And it makes sense to us to kind of follow that model in order to understand it. So because we already know about the multi-store model of memory, you could use that as an example of a theoretical model showing the, how information is processed into long-term memory. So we know that the environmental stimuli around us, all of that environmental stimuli will go into your sensory memory, which has certain characteristics. So the capacity is unlimited, the duration is only milliseconds, and the coding is dependent on the sense that you're using. And then, so all of that information goes into your sensory memory, but if we pay attention, so the second arrow across, if you pay attention to that particular sense, then it will get transferred to your short-term memory, which has characteristics which you should hopefully know. If you engage in maintenance rehearsal, so if you kind of repeat that information over and over again, then that will stay in your short-term memory. Or if you do it long enough, then if you're one of my students, you will know that it goes whoop, straight over to your long-term memory, so it gets transferred to your long-term memory. You can see some other arrows there. So if you don't recall, rehearse the information, then that information will just decay or displace. But you can also retrieve information from your long-term memory store into your short-term memory store to kind of talk about that memory for as long as you like, and then you can just forget about it, but it will stay stored in your long-term memory. So the theoretical models are part of the cognitive approach to really help us explain, like give us this idea, this framework for how internal mental processes occur. And, you know, use the model, if they ask for an example, use the theoretical models that you've already learned about in things like memory. Within the cognitive approach, we also have computer models, and this is the idea that the mind is compared to a computer, so we call it the computer analogy, by suggesting that there are similarities in the way information is processed. So the models use the concepts of a central processing unit, the brain, the concept of coding to turn information into a useful format, and the use of stores to hold information. And such computational models of the mind have proved useful in the development of thinking machines or artificial intelligence. So the cognitive approach, you know, when you look at that picture, you've got a computer there with a person inside it. It's kind of comparing our brains to a computer and using that same terminology that is used in computing to make a comparison to human brains. Within the cognitive approach, you need to know about schemas, the role of schemas. So a schema, have a look at that picture there. You can see an empty box, and imagine that in that box could be information or knowledge about anything, but each schema is like a separate box. So you have schemas for absolutely everything. So a schema is a packet of knowledge about the world, and each packet of knowledge is about very specific things. So for example, you have a schema of shoes. So imagine I'm just looking at a big pile of shoes, which is why I'm talking about that. So your schema for shoes are that they are things that you wear on your feet, and then you've got other information, so they might be made of leather or material, or you might have laces or Velcro to do them up. You might have high heels, you might have platforms, you might have trainers, you might have boots, but all of that information about what shoes are is your schema for shoes. And certain shoes mean certain things, like for example, if you're wearing trainers, they might indicate that you're exercising, but they might not. It might just be your style. So schemas are there because they act as a mental framework for the interpretation of incoming information received by the cognitive system, which means that we have a schema for everything, and it means that as new information arises and like new things happen every day in your life, you're ready for them. You've got this packet of knowledge of what they are and how to deal with them, even if you've never seen it or experienced that thing in real life. So cognitive processing is affected by your beliefs or expectations, which we refer to as a schema. So it means that the way you process information is affected by your schemas, by your kind of pre-existing knowledge of that thing. So I'm going to explain that a little bit more, or why we use them. So the role of schema, partly schemas enable us to process lots of information very quickly, and this is useful as a kind of mental shortcut that prevents us from being overwhelmed by environmental stimuli. So wherever we go and whatever we do, we've got a schema for that thing that we're doing. Like if you, so for example, let's have a look. So this, I had a look at some pictures of sixth form colleges on the internet, and I found this college here that's in London, and I found this sixth form college here, and they look very, very different, and you might attend one of those sixth form colleges. Think about your own sixth form college now, like what does it look like? But it means that because you are probably attending a sixth form college, if you're listening to this, then you have a schema, you have a packet of knowledge of information about what they are and what to expect. So no matter if you went to the first sixth form picture or the second one, you would expect there to be teachers, probably classrooms, desks and chairs, students, people wearing lanyards. You'd expect there to be a canteen area. You'd expect there to be a LRC, a learning and resource centre, which might have computers in it. You would be expecting probably not to have to wear a uniform, because most sixth forms you don't. It's that extension on from school. Maybe have a bit more freedom, have free periods, have like friends. So you've got all this information so that if you went to a brand new sixth form, supposing you were doing an exchange and you went to go and do some work in a new sixth form, as you get there, even though you've never been to that new sixth form, you know what to expect, and it means you can process that information really quickly because you've got an idea of what is going to happen. I quite often refer to airports for this. So if you've ever flown on an aeroplane, then you'll have been to an airport. Even if you haven't, you will have a schema for airports. Even if you've never been to one, you will have this knowledge of what happens there. So you would know that you would have to take a passport and have tickets, and there'd be duty free, and there'd be places where you'd have to sit and wait, and that you can't take liquids, and you've got all this information. If you go to a new airport, it might be a different country, but you know what to expect, you know, like baggage handling and which gate to go to and what to look at. So it means you're processing lots of information very, very quickly because you've got this pre-existing knowledge, your schemas for what something is. So cognitive processing can be affected by a person's schema. Like we've just said, you know, you can process information cognitively very quickly. However, another important thing is that schemas can distort our interpretations of sensory information, leading to perceptual errors. And that means, what that means is what we expect to see based on our schema interferes with what we think we see or what we remember. It can distort your perception of something, and it can distort your memory for something. So for example, have a look at this car here. And I put their schemas act as proactive interference. So if you've done the memory unit, you will know that proactive interference means that your older memories, your pre-existing memories, will interfere, block or distort your newer memories. So schemas are basically proactive interference. If you have a look at this car, your schema will give you a stereotypical and prejudiced view of who owns that car, how they drive, and what they're like. And the way that I got this image was to go into Wikipedia, because you get free images from there, and I typed in boy racer, and this is the image that it gave me. So probably looking at that car, you would imagine the type of person to be driving it would be a young man who drives extremely quickly. Now that might not be true. It might be that it's a 87-year-old grandma who's got this, or just an 87-year-old woman who has got this car, and could be driving it slowly or could be driving it fast. But imagine if you were walking down the road and that car, whoever was driving it, speeds past you, I don't know, hits someone, has an accident and drives off. When the police interview you about that, the likelihood is that your schema for what you expected to happen will interfere with your actual memory for the event. So it's likely that even if you didn't see the person, or you just glimmered or glanced, you know, you caught a glimmer of the person, that you would report that it was a man who was driving, and you'd probably say a young man. And yet that might not be true. You might have just seen a tiny fleeting glimpse of a person, and your schema has filled in the blanks for you. And so that means that schemas are proactive interference, because they have your stereotypes and your prejudices of those newer memories that, sorry, your existing memories, your schema are basically have been built up, and that acts to distort your perception for what you actually see. So this is the last part of the AO1. There's a lot, isn't there? The cognitive approach has a lot of information. The last part is the emergence of cognitive neuroscience. So cognitive neuroscience is the scientific study of the influence of brain structures on mental processes. And I've put there, what does that mean? Because chances are you heard that and it just washed straight over you. So let's look at that again. Cognitive neuroscience is the scientific study of the influence of brain structures on mental processes. So when we're talking about mental processes, mental processes are ways that we think that are unobservable to the naked eye, like language, memory, and perception. And so what cognitive neuroscience does is to look at the brain structures that are important for memory, language, and perception. And even before we had like brain scanning techniques, people way back when have been trying to map, you know, which bit of the brain is responsible for which function. So way back even in the 1800s, Broca identified how damage to an area of the frontal lobe could permanently impair speech production. So the brain structure, the frontal lobe, was involved in the production of the process of speech. And so that was before we had brain scanning technology. So people have always wanted to do it, but in the last 20 years we've had brain scanning technology such as PET scans and fMRI scans that allow us to scan the brain and identify which areas are functioning for different mental processes. So when you look at these pictures here, you can see a guy lying down, and he's actually in an MRI scanner, which is a magnetic, it means functional magnetic resonance imaging. So it uses very, very, very strong magnets. And usually you go in an MRI if you're going to have part of your body scanned. So for example, I had a bad back once and they stuck me in the MRI to have a look at what was going on. But functional magnetic resonance imaging means that the functional bit means that you are going to be performing a task when you're in the scanner, and so you can see that man has got a pen in his hand and he's actually looking at something, and he's being asked to do a function every time something occurs on the screen that he can see. So while he's doing an activity, if you look at the picture of just above that one, is somebody analysing what's going on in his brain. So when you do perform a certain function, blood oxygen will rush to a certain part of the brain that is performing that function, and we call that the hemodynamic response, because hemo is blood, so blood will rush to that area, and on the screen it looks like the brain is lighting up. You can't write that in the exam, you can't say the brain lights up, they don't like it. The technical term is the hemodynamic response, and it means that blood oxygen is rushing to that part of the brain. So we can actually see which structures in the brain are responsible for particular internal mental processes. So there was a researcher called Tolving who showed how different types of long-term memory may be located on opposite sides of the prefrontal cortex, so your episodic and semantic memories. And as well as this, the system and overall charge of the working memory, the central executive, is thought to reside in a similar area. And they've done this through like the use of cognitive neuroscience, through the scanning techniques. Cognitive neuroscience and mental health disorders. So if you so scanning techniques can also, they have been useful in establishing the neurological basis of some mental disorders. So there's found a link between the parahippocampal gyrus and OCD, and they think that it appears to play a role in processing unpleasant emotions. So it means that cognitive neuroscience can kind of establish brain structures that might be important for particular mental health disorders. And the picture on the screen is, there's obviously some kind of investigation that was going on to do with like autism, to do with visuomotor coordination for people who are autistic compared to a control group. So it's really showing how there is a neurological basis for some mental health disorders. So that's another role of cognitive neuroscience. And then a final thing to say about cognitive neuroscience is that the focus of cognitive neuroscience has expanded to include the use of computer-generated models that are designed to read the brain. And this has led to the development of mind mapping techniques known as brain fingerprinting. And I have put a link in the description for you to click on a video, but skip the first 60 seconds because it's just a kind of introduction. But if you watch that video, you can see somebody talking about brain fingerprinting and how it's been proved really useful to do with criminal activity. So the brain waves will either match the crime, so the person committed the crime, or the brainwave activity that is when they do this brain fingerprinting will match an alibi, which shows that maybe they didn't do it. And on that basis, there was a criminal in America who was exonerated, like after years though of being in prison. But they think that a future application of that is that it will be used, once it's been developed, it will be used perhaps more readily when talking to eyewitnesses in court to see if they're lying, that kind of thing. So cognitive neuroscience has many, many benefits, really. Okay, so that's the end of the description, the AO1 material. And so we're going to look at some of the evaluation points. And the first evaluation point is a strength, and it's just that the cognitive approach is very scientific and uses objective methods. So objective means factual, scientific methods. So the cognitive approach has always employed highly controlled and rigorous methods of study in order to enable researchers to infer cognitive processes at work. It has involved the use of laboratory experiments to produce reliable, objective data. And the emergence of cognitive neuroscience has enabled the two fields of biology and cognitive psychology to come together. And this means the study of the mind has established a credible scientific basis. And so what this is really saying is that, you know, psychology is a science, and the cognitive approach has kind of really helped in developing it into a science because it uses such highly scientific techniques like brain scanning methods, but also all of the experimentation that is done is really well controlled, well designed, has high internal validity, and it means that the inferences that are made are highly scientific and very credible. And so that's a really good thing for psychology and the cognitive approach. A limitation of the cognitive approach is that it is it's criticised for being what we call machine reductionist. So in the AO1 we talked about how the computer analogy and how the brain is compared to a computer, but we're not machines. You know, we are human beings and we have emotions. So although there are similarities between the human mind and the operations of a computer, like input, output, storage, the use of a central processor, the computer analogy is criticised. So machine reductionism is what it's called, and it says it ignores the influence of human emotion and motivation on the cognitive system and how this may affect our ability to process information. For example, research has found that human memory can be affected by emotional factors such as the influence of anxiety on eyewitness testimony. So what that means is we know that it says there, how does the multi-store model of memory, or the MSM, say that memory gets into long-term memory, how information gets into long-term memory? So, you know, when we think about that theoretical model that we looked at, and it's that lovely linear model, and we get information around us and it flows through all the stores, and if we rehearse it then we can remember it, etc. And that's a lovely, very neat model of how information is processed into memory. But the Swedish bank robbery study, if you remember the findings of Christensen and Hubinette's natural experiment on Swedish bank robbers, or Swedish bank robberies, was that the victims of those robberies, so the people who had like guns pointed at them and they were absolutely terrified, they had incredible recall for the event, and they were interviewed 4 to 15 months later. Because the human emotion of anxiety absolutely threw the multi-store model of memory out the window. It wasn't, when you put a human element, emotion into the mix, like anxiety, then you can, all the theoretical models are just too neat. They don't really account for that human element of being really frightened, really, really anxious, and how that changes the processing of memory, how that means like those memories became so clear so quickly, and so we can really criticize the cognitive approach for being machine reductionist. You can't reduce human beings and their brains into a neat computer, because we have human emotion that affects us differently. So you might want to just pause the video and have a look. I've written an evaluation paragraph for you there. So you can pause that and use that if you want to use that as your evaluation. A strength of the cognitive approach is the real-world application of it to policing. So the cognitive interview says describe the cognitive interview. So pause the video and write down the 4 elements of the cognitive interview. Welcome back. I presume you have just put down report everything, recall, context reinstatement, recall from change perspective, and recall in reverse order. And 2 of those elements of the cognitive interview were developed through the cognitive approach to avoid schemas from interfering with real memories. So the 2 elements are the recall from change perspective and recall from in reverse order. And the reason is that the reason they help enhance recall and the accuracy is because they're very, very difficult to do. So first of all, people have to think really deeply, which aids recall. But the bit that is really developed from the cognitive approach is that because we're aware of schemas and how they influence and distort our memories, when we get people to recall in reverse order and recall from change perspective, that means that they having to concentrate so hard that it blocks the schemas from interfering with their real memories. And so you end up with a more accurate memory. So, my example of the boy racer, that stereotypical thing, apologies to any young men out there who are drivers, you've been labelled wrongly or rightly in your own case. But, if you saw a car like speeding down the road, if you were asked to recall it in from change perspective, then you would probably be able to recall it more accurately, because you would be blocking your schemas from interfering with your real memories. Like the real memories would stand out much more clearly, and you wouldn't be just churning out stereotypical information. So I put there, write a 60-word, about 60 words to evaluate that particular one. Again, I've written one there for you, so you can pause the video and have a read of that if you'd like. And this evaluation point is about its research support for that stereotypical information distorting your memories. So this picture is from a study by Allport and Postman in 1947 in America, and it's called the Black Man, White Man Razor Study. And in the study, participants went to a laboratory and they were shown the picture. I'm not quite sure, they must have been shown other things as well. But a week later they came back to the laboratory and they were asked to describe that picture. And most people described it the opposite way around. Most people described it that it was the black man threatening the white man with the razor. Now this was 1947, when racial prejudice was even more discriminatory, existed even more than it does today, which obviously is completely unacceptable, but unfortunately there was discrimination back then in the way that there is discrimination today. So what this did, it highlighted people's schemas for their racist schemas, because people had their memories distorted by their schema, by that proactive interference of prejudices and stereotypes. So this provides evidence that schemas unfortunately will distort our perception and our recall for events. And I've put two things there. One, explain how schemas cause proactive interference. For 2 marks, you could try doing that, pause the video. And the other is to write an evaluation paragraph to provide evidence that schemas do distort our perception and our recall. So pause the video and have a go at that. And that was my answer there. So again, you can pause the video and have a read of those. And the very last evaluation point we've got here is a strength of the cognitive approach in its real life, real world application. So the cognitive approach is probably the dominant approach in psychology today and has been applied to a wide range of practical and theoretical contexts. For example, cognitive psychology has made an important contribution in the field of artificial intelligence and the development of thinking machines like robots, exciting advances that may revolutionise how we live in the future. So you can see there a drone who is distributing a life thing to someone who's in the sea. So cognitive psychology is actually involved in developing those artificial intelligent machines. Okay, so first of all, make sure that you fill in that handout AP22, just so you've got a big summary of the cognitive approach, and then you can have a go at some of those questions like outline the emergence of cognitive neuroscience for 6 marks, and briefly explain how theoretical models are used in cognitive psychology to make inferences about mental processes, 4 marks. I'd also like to have a go at the 12 marker, because we know in 2022 that the cognitive approach is definitely coming up on the exam, so you need to be completely prepared. So this video provides enough information for a 12 marker. So you would describe the cognitive approach for 6 marks, and that's quite a challenge. There's a lot in there. You've got the basic assumptions, you've got to mention about inferences, theoretical models, computer analogy and schemas, and maybe even a bit of cognitive neuroscience as well, which is huge for just 6 marks. So you'd have to really summarise the parts, and then evaluation. So 3 evaluation points, strength and a weakness, and then 1 other. If you're my students, you're going to have a mini mock exam on approaches and research methods on Friday the 25th of March. But remember, you will only be tested on things that are definitely coming up in the exam. So check the advanced information. If it's not 2022, you'd have to revise everything. And I believe that's it. Okay, thank you.